Okay, so proving log identities. So these are the 4 basic log identities. Gather? Good. Notice different letters are used on your formula sheet. They use M's and N's. Doesn't make it any different. Same identity. Okay, so I don't know why we have that on the same separate page. Okay, so we're going to use those to prove each of the following. Again, confuse a little bit. So let's do C together. So, just like with trig identities, we want to, or one method of doing it is looking for the more complicated side and trying to use identities to get it to be the less complicated side. Okay? So I would say this is more complicated, so I'm going to copy that out. Okay, so what I want to do, I'll write out the second side. So I want to make this be this. So take a look. I always look at, because they're both just one term. So obviously you're not going to use the product law or the quotient, because they're both one term. But this base is B. This is B to the N. So use the change of base formula. So that change of base, if I want to change this to base B, then I do it in both the numerator and the denominator. Again, it's an identity that we're proving, so we want to show all of our steps. So I'm changing my base. The original argument stays the same. The argument in the denominator is the original base. Okay. Then this is now the log of x to the n, so we can use the power law. So that n ends up being the coefficient. Here, the power law as well, but we've got the base and the base of the exponent being the same. Remember, we did that yesterday. That's going to end up being n. So that one you can just do in your head. Then the n's divide out. And the left side equals the right side. And probably a good idea to state what this is defined for. So x has to be greater than 0. Probably, you should practice on a test if you're asked to prove this. State that b is also greater than 0, not equal to 1, the base of that log. Okay, and then you would state yes, that is. Yeah. Although we might actually put that into the actual question. D, you can do the same method, change the base. So I'm going to use that one for you to do on your own. And basically, once you've done that, you might actually use that right away. If you're simplifying a log expression or solving, if this, okay, we're comparing a base of 1 over a, argument is x, that's the same as negative log of base a of x. Okay, so it's just something to be aware of, but you can prove that on your own. So let's switch to f. This is a product of 2 logs. Notice how the bases are different. Even if they were the same, there's no special rule for the product of 2 logs. Right? If you were adding those 2 logs together, you could take the product of the arguments, but we're multiplying. So, left side, right side, copy these out. is more complicated than the right side. Right? Because the right side is just one log expression. The left side is two. Take a look. These are different bases. Same argument. This is base B. So I want to try to change a base A to a base B. Right? There's no base A's over here. So if I do that, use your change of base formula. Okay, so this I'm going to replace with log base B. Right, that change of base formula, the original argument stays. The denominator argument is the original base. Oh, what did I say? I copied this down wrong, didn't I? I need to fix this. I copied it, that part down. Okay, there and there. Now it's good, right? So I just put X there by mistake. This is A. Just copy that out, and now you'll notice that that's the same as that. Okay, and likely in the stem of the question, it would already tell you that A and B are positive. I'm not going to prove this, but it's the same method that you've been doing, change of base. But take a look at it, and it's kind of a handy identity. If this is 1 over b, this is 1 over x, that's going to be the same as log of x, taking the reciprocal of both. And again, you can do that with change of base. You can use that on your own. Let's look at I. Kind of fix up I a little bit. It didn't print properly.
Yeah, let's go.
Yeah, so here, if you could please put brackets around x plus y. Brackets around that triangle.
Yeah, I kind of see that.
Okay, there's a little, you can see there's a bracket 3 log. You've got whatever happens. If you don't have those brackets there, then really that's log of 1, which is 0, plus these variable terms, right? So it's not going to be something that you can. Okay, so more complicated side is the right-hand side. Okay, so take a look at that. It's the sum of 2 log terms with the same base. Coefficient here is not 1. So if I want to use that product law that says where you take the sum of 2 logs with the same base, you multiply the argument, I actually need to use the power law first. If you wanted to find a common denominator and collect these terms together into one term, you can. I'm just going to leave it as is right now. Now I'm adding logs. The coefficients are 1 in each, and those are A's. So it's going to be the product. Multiply through by x squared, because you know this can get rid of the denominator. complicated than the left side. But take a look at the left side. It's got a coefficient. The 2 in front of that law, using the power law. So you could still keep working here. I'm actually going to go to the left side and work with it a little bit. And then x plus y squared, well, if I expand that out, I get that. Or if I factor this, I get that. So you decide which side you're going to work with. If I expand it out here, and then in terms of restrictions, you would have to, x plus y would have to be greater than 0. That has to be greater than 0, but actually that is going to be.
Yeah.
Separately is good. And here, that's going to be
Whatever.
good, because even if these are negative, 2 negatives give you a positive, so a whole thing will be positives. Specifically up there, x has to be greater than 0. Okay, so that just gives you some a little bit of practice on proving identities. You can work on the other ones on your own time. Okay, a little bit of practice, and we want to get into the good stuff, which is solving equations.